All right, so today we'll be talking about sample spaces and counting. Okay, now sample space is just the set of all possible outcomes of that experiment. So whatever experiment you're thinking about working with, sample space is just all the possible outcomes that's going to happen. It's almost like if you're working with a thought experiment, it's like what could happen, what could literally happen, and then you have to account for that because if that could happen, that would be that. So for example, if you're rolling dice, there would be six outcomes because there's six sides. You're not going to have a seventh side. The counting, or the fundamental counting principle, is a way to figure out the total number of ways that different events can occur. So, for example, most famous is possibly going through a buffet line or some kind of event like that. So, let's say you have five dinners to choose from, four sides, and six desserts. Okay, how many possible meals could you have? Okay, so that's five dinners. So that's five possibilities. Okay, and then it's four sides. So four sides per dinner. So that's a total of 20 outcomes. Then times that by six. Okay, and you're going to have 120 meals that you could have just from that combination alone. I know that in the past I've had students look at Porta Subs menus and Subway menus, and they've actually figured out that uh, Subway actually has less combinations than Porta Subs does. And it was interesting because we just used the fundamental counting principle. Okay. All right. Now, one thing, pretty self-explanatory. Event is just something that happens. Okay. All right. So just don't be fooled into thinking like it's something more. It's something that pretty much happens, whether it's rolling dice, counting cards, picking items, whatever. Okay, now two things that should help you out when you're working with probability is the probability of any sample point can range from 0 to 1. Okay, and the sum of probabilities of all the sample points in a sample space is equal to 1, and that's always going to be true. Okay, and the probabilities we're talking about are going to be definitely the decimals. Or, sorry, not the decimals, either the decimals or the percentages. Okay. All right, now here's some possible outcomes, some possible sample spaces that most people tend to forget about. Like, for example, coins. You got two outcomes. Uh, Real fast, let me expound on that. That's one coin. Two coins would actually have four outcomes. Okay, because it is two coins and two coins on the other side, so it's going to be 2 times 2. That's using the fundamental counting principle to get there. Okay, three coins, most people are going to say, oh, it's 6. Nope, it is 2 times 2 times 2, so possible of 8 outcomes. So if you were to draw a tree of choices, you would understand where these numbers are coming from. All right, four coins would be 2 times 2 times 2 times 2, which would be 16 outcomes. Okay. All right, and that actually makes sense with dice. Okay, so dice could be 6 outcomes for one die. We should probably change these wordings. So let's change these bad boys. Let's change that to coin, and die would be die. Okay, so that's singular. All right, so that would be 6 outcomes for one dice. Now, two dice, you have 6 choices for the first dice, 6 choices for the second dice, so a total of 36, not 12, 36. And if you roll 3 dice, which is just crazy, it's 6 times 6 times 6, which is 216 possible outcomes. Okay, deck of cards are 52 outcomes, 52 cards, 52 outcomes. Depends on what you're picking. So, for example, if you're uh, taking a look at, what's the probability of getting, all spades, or what's the probability of getting at least one spade? you would have 1 out of 4. Okay, because it's 13 out of 52, because 52 is the total amount of cards. Now, 2 decks of cards is what you usually deal with at a dealership, or not a dealership, but a casino with the dealers, because the total number of outcomes is now 52 choices times 52 choices for 2,704 outcomes just for 2 decks. If you can imagine 3 decks, that's just crazy. So if you ever find yourself and being of gambling age and you'd like to go gamble with cards at the best possible place, find a place that does 1 deck of cards. It's really nice. Okay. All right. So anytime you want to deal with sample spaces for probabilities, always take time to write out the sample space ahead of time, or what possible situations can happen and at what combination of. Okay. So please understand, if you take that time to write out the sample space ahead of time, it makes your headaches in probability a lot easier to deal with. Okay. Thank you and have a great day.